Okay, last lesson we looked at disproving a conjecture, and that's what we start today's lesson, 7.4, day 2, midpoints and medians. We start this off by trying to confirm or disprove this statement here. Blaise Pascal has the following mathematical hypothesis, that x over 2 is always, and you want to look out for that word right there, is always less than x. Is x divided by 2 always less than x? We can test this by doing a couple of things. So we could make a little table of values if we wanted to. And we can say here we'll have the value of x, and here we'll have the value of x divided by 2. And so let's just do a couple examples here. And I might want to continue this up here. So for example, we'll have when x is, we'll do -3, -2, -1. Let's do this. Copy the same thing here, and we'll draw a line there. We'll have x divided by 2, and let's try and also do when x is equal to 0, 1, 2, and 3. So when x is 0, 1, 2, and 3. So when x is -3, x over 2 would be -3 over 2, which is equal to 1.5. I really don't need this line here, do I? Equal to 1.5. So in this case, x divided by 2 is actually greater because negative 1.5. That's bad form. Negative 1.5 is greater than -3. When x is -2, then we'd have -2 divided by 2, which is -1. And of course, -1 is greater than -2. When x is -1, we'd get -1 divided by 2, which is -0.5. And clearly that's greater. When we have x is 0, then 0 divided by 2 is equal to 0. So they're the same. And when x is 1, then we start getting 1 over 2, which is 0.5. And of course, now x is greater. When x is 2, 2 divided by 2 is 1. That's less. And when x is 3, 3 divided by 2 is equal to 1.5, which is, of course, less. So it is not always true. So it asks us, is he correct? The answer is no, it's not correct. The reason is when let's do this properly. Let's see if I can get some room here. When x over 2 is greater than x, when x is less than 0. So when x is less than 0, or equal to, sorry. No, when x is less than 0. So x over 2 is greater than x when x is less than 0. And we've got our example right there. So when x is less than 0 means when x is a negative number, right? When x is a negative number, then x over 2 is actually greater than x. Here is an example of one of the learning goals you learned yesterday, and that is when you join the midpoints of two sides of a triangle, you create a line that is automatically parallel to the third side. This one's been rotated, but so I'm actually going to start with this one right here. It's a little bit easier to start with. So this line here and this line here would be parallel if and only if this is in fact joining the midpoints of this and this, or AC and AB. But we can tell from the drawing, it's very clear because we have this as being 9 units, that's 7 units. If they were 9 and 9, then we know that point D is in fact in the middle. But one is 9 and one is 7, so it's not joining the midpoint. If it's not joining the midpoint, then we can't confirm that it's in fact parallel. It looks parallel in the drawing, but we can say it's not parallel because, again, this is 9, that's 7. On this side we have 5 and 3, not 5. So that's a diagonal, but not 5 and 5. So this line is not parallel to this line. So DE is not parallel to BC. Now we're looking at the same type of figure, but we're looking at this one rotated here. Now we're looking at this one here. And if you note, this is 6, this is 9, so therefore we can't confirm that this is equal in length, and we can't confirm this is equal to this because one is 2 and one is 3. Therefore, because the line DE, the line DE is not equal to, is not, does not, is what I want to say, does not join the midpoints. Therefore, it is not parallel, and the short form for parallel would be this: two parallel lines is not parallel to the third side. And that's it. The next question, and the final question, I'm going to leave this with you as a bit of a challenge. So what is a Pythagorean triple? So I want to encourage you to go online and look up what a Pythagorean triple is. And you can look up for multiple Pythagorean triples online. You'll find this almost any website. Math is Fun has multiple examples. But I just want to point out one thing here, so just to give you a hint. So a Pythagorean triple, this triangle right here is 3. We know that that is 3 units. Sorry, 4 units, I apologize. 4. This is 3. From 0 up to 3 is 3. And then we know that's 3, 4, and this is automatically 5. We know that because it satisfies the Pythagorean theorem. We know a squared plus b, a squared plus b squared equals c squared. If that's the case, then we know 3 squared plus 4 squared must equal c squared. That's 9 plus 16 equals c squared. That says 25 equals c squared. And the square root of 25 equals c, or 5 equals c. And we know that that is indeed true. So 3, 4, 5 perfectly satisfies the Pythagorean theorem. Therefore, we say that 3, 4, 5 is, I'm going to just do PT, Pythagorean triple. Okay? There are multiple other Pythagorean triples, like I said. Please go ahead and try and find those. And how can this help you find the entire area of the larger triangle? So how would that help you find the area of this entire triangle? See if the Pythagorean triples will help you here. Okay, and we'll take that up in class. Take care.